symbol for congruence. When I say two things are congruent, what symbol do you use, Nico?
It's like the equal sign with like the enye.
It's the equal sign with the enye, the tilde over top, right? Okay, so if things are similar, they are not equal anymore. There are things that are equal about them. It's just the little enye symbol. It's the tilde. So this is the similar figure symbol that we will use. So whenever you see that, don't think congruent, think similar. Okay. Similar figures are going to have the same shape. So if it's a triangle, it's going to look like the same triangle that just got blown up or shrunk down, because they will not necessarily have the same size. Okay. Maybe that's something like this, right? I could say those are similar triangles. They look the same, but one just got blown up a little bigger than the other one, okay? So when we talk about similar polygons, that could be triangles, that could be quadrilaterals, that could be pentagons, right? Any polygon can be similar to any other polygon. The thing that makes them the same shape but not the same size is that they will all have corresponding angles. So the angles that match up, right? Those are corresponding angles that are congruent. I'm just going to do the congruent symbol. If you like the word better, you may put the word in there. Corresponding angles that are congruent, but then the corresponding sides aren't congruent, right? If you look at this picture, you can see these angles look the same, and these angles look the same, and the third angle looks the same, but it is definitely not true that this side is congruent to that side, right? Those don't match up. So instead of being congruent angles and congruent sides, it's congruent angles, but proportional sides. Okay, which is where our ratios and proportions come into play. That's why we talked about those yesterday. So yes, I can say in this figure, angle A is congruent to what angle, would you say? Angle E, okay? Angle D would be congruent to angle H, okay? And you can keep going. List all four as congruent. These are congruent. These are congruent. These are congruent. And these are congruent. I'm not going to keep listing them all, but they would all be congruent angles, okay? The sides are proportional. So the way we do that is we set up ratios of our sides and we set them equal to each other. So for instance, I could say that segment AD corresponds to what segment? HE. Okay, so AD to HE will equal, now here's where you have to be a little bit careful. If I started at AD and I went to HE, then I have to go back to that big figure, and all of my top numbers in my proportion should be from that first figure, okay? We don't want to flip that because then that's not a true proportion anymore. So if I moved to here, I would say AB corresponds to what? EF. Okay, keep moving here. BC to FG. Does it matter if I call it GF? No. And the last one would then be DC to HG. Okay, so notice we're not saying the sides are congruent. We're saying the ratios are the same. The comparison of the sides will keep equal. So that's how we're going to set up similar polygons. Let me show you when there's actual numbers and angles involved. When we do this, it gets us what's called a scale factor. And a scale factor is just the ratio of all the sides, how they relate to each other. So in this case, can anyone tell me what the scale factor for this problem would be? It's 1 to 2, right? You're basically saying 15 to 30 is equal to 20 to 40, right? We're matching up those corresponding sides, which is equal to 25 to 50. Okay, but like we said, we always want to reduce. So that means every one of these reduces to the same thing, which is 1 to 2. Would it be okay for me to call this a 2-to-1 ratio?
Yes.
It would if we were talking about the first or the bigger figure to the smaller figure, right? If I said HIT is similar to FLO, I would say that's a 2-to-1 ratio. Because they didn't give us like a statement for it, then we just go in the order they gave it to us. So technically, in the order they gave it to us, it's 1 to 2. But if you were talking about them in reverse order, it's 2-to-1, okay? So if they give you a statement like this, go in that order. If they don't give you a statement, go first to second, okay? All right, example 1. I'm gonna have you set this up because it's exactly what we did up here, okay? You may work with someone around you and talk it out loud, or you may just write it down. I'm telling you triangle QRS is similar to triangle DEF, okay? So be careful. You might not want to use the picture. You might just want to use the letters and go in order, right? It's the first, second, and third letter with the first, second, and third letter. If you don't want to mix things up because you're trying to rotate a picture around, tell me which angles are congruent. So you're doing this. List all the congruent angles and list the proportional sides. Give that a go. All right, angle Q is congruent to what? Angle D. Angle R is congruent to angle E. So the first with the first, the second with the second, and the third angle S with the third angle F. Okay, so those are congruent angles. If it helps you to mark them, you're welcome to mark them. You don't need to, but maybe it helps you to see the rotation a little better. That's fine if you want to do that. Sorry, that's really messy. Okay, now your extended proportion. Something over something equals something over something equals something over something. Anyone want to give me their whole thing? You gave me one already. I want to see if someone else wants to give me one. Oliver, you want to give me one? QR over DE equals RS over EF and Q over DF. Good, perfect. So you're just matching up those corresponding pieces. Any questions on that? All right, moving right along. So this one, notice in example 1, I told you these triangles are similar. So you don't have to do any checking if they are. It's just here's the pieces that match up. This next question asks you, are they similar? How do you suppose you could figure that out? They give you some numbers. How do you tell if they're similar or not? What would have to be, yeah.
You have to put them in try to find the ratio.
Find the ratio, right? Find the scale factor of each set of sides and make sure that scale factor is the same, right? Or set up an extended ratio and make sure they truly are equal ratios, okay? Or an extended proportion, sorry. So take a look at this question. The first triangle, I would say, is the bigger triangle. So I would probably start with the 16. But what is the 16 going to relate to? The 8, okay? Now people are always like, but how do you know that? Well, pick the smallest one with the smallest one, because if you pick the smallest one with the middle one, there's no way it's going to be similar, right? But if you go smallest with smallest, biggest with biggest, middle with middle, you have a chance. So 16 with 8 is the one. What's another one? 30 is your middle number. 15 is your middle number. Again, notice she did not tell me 15 to 30, right? That would be different. Make sure you keep going in the same order all the way through. And then the last one? 34 to 17. Okay, so then you check it. reduce all of those. You get 2 to 1, and 2 to 1, and 2 to 1. Are those polygons similar? Yes. Okay, so here's what it says. If they are similar, write a similarity statement with the scale factor. Okay, here's what a similarity statement is. You say triangle, if I say DEF, remember we did this with congruence? They're not congruent, they're similar. What symbol am I going to put next? The little tilde, right? So triangle DEF is similar to what triangle?
CBA.
DEF would be CBA. With a scale factor, you may just write SF if you want. And what was our scale factor? 2 to 1. Okay, now question. Could I say triangle CBA is similar to triangle DEF with a scale factor of 2 to 1? No, 1 to 2, okay? That's a great answer too. So if you want to flip it, that's fine. This similar to that, but then you have to flip your scale factor. I'm telling you, that's probably the thing I see done wrong on the quiz or test the most, is people know it, but they're telling it wrong, right? If you're going to go in reverse order, then you got to flip your scale factor, okay? Good on that? Okay, how about this one? See if you can write, we'll see if these are similar. If so, write a scale factor. If not, why not? Work it out. Feel free to talk to your neighbor about it. What kind of figures are those, by the way? It's a rectangle. Why is it a rectangle? 4 right angles. Chapter 6, huh? All right, similar or not?
No.
Why not?
Different ratio.
Different ratios, different scale factors, right? So the 10 would correspond to what number?
16.
The 16. The longer with the longer, right? And then the 4 with the 6. If you reduce those, 5 to 8 does not equal 2 to 3, right? So you would just say these are not similar. You don't need to do a similarity statement because they're not similar, so we can't write a similarity statement, so you just leave it like that. Any questions on that? All right. Example 3 here. They tell us here that ABCD, so that's the bigger figure, is similar to EFGD. And when they want to know what are the values of X and the values of Y. On a problem like this, we need a scale factor. We need to know what is the comparison of these two figures. Can anyone tell me what the scale factor should be? What'd you get, Nico?
It'd be 9/6, because, right, those are the corresponding sides, and then you divide them by 3/2.
Okay, why not 2/3?
Because I said the big one first.
Did you say the big one first?
Oh, it said the big one.
They said the big one first, right? So if they give you this order, right, stick with the order. The bigger to the smaller would be the side here to the side there, right? So 9 to 6 is going to be the scale factor for the whole figure because they told us the figures are similar. So a 9 to 6 ratio would reduce to 3 to 2. Okay, so I know the comparison of this whole problem is 3 to 2, bigger to smaller. How can you solve for X then?
But you have to flip it. And then multiply.
You don't need to flip it. Is it your mom?
No.
Want to talk to her?
Random caller.
Oh, love it when that happens. So 3 to 2, right, is our scale factor. If we're going to set up a proportion here and solve for X, where's X going to go? Top or bottom? On the bottom. Because we went bigger to smaller, we need to go bigger to smaller. This is the smaller figure. What's the bigger there that corresponds to it? 7.5. Okay, so here's your proportion. Now, question. if I had flipped it 2 to 3, could I have set it up 7.5 over x? No. Could I have set it up x over 7.5? Yes, right? You just have to keep the corresponding parts with each other. Could I have set it up that 9 over 6 equals 7.5 over x? You'll get the same answer, right? It's going to get you bigger numbers in the cross multiplying, but once you divide, you'll get the exact same answer. So if you don't like to reduce the initial scale factor, if it helps you to see that it's the 9 to the 6, you could totally say 9 over 6 equals 7.5 over x, and you'll still get the same answer, okay? Sometimes I think that's a little easier because you can just see the numbers instead of the reduced version of it. So that's up to you, how you want to do it. This is nicer because they're smaller. So you get 3x equals 15, and you divide by 3, so x is 5. Okay? You set it up for y. See if you can solve for what y should be here. And feel free to talk to your neighbor. You guys are awfully quiet today. I know, it's new people around you, but I don't mind the chatting, I promise.
What is that? Yeah.
What's that? Because we want the whole thing. Okay, what did you get for y? 3.3 repeating as a fraction, that would be 3 1/3, right? So if you set that up, you can say 3 to 2 or 9 to 6 if you don't want to reduce it right there. If it's 3 to 2, it would be 5 to y, and then you would cross multiply. So 3y equals 10, divide by 3. So y is 3 1/3. 3.3 repeating is fine. Don't call it 3.3 because that's a different number. That's 3 3/10, right? So 3.3 repeating or 3 1/3 or even 10/3 is fine for that. Good? Okay. I'm actually going to skip this one. Are you okay with skipping a problem?
Yes.
I took it out of the homework, so if you want to try it, you're welcome to. But we're not going to do it this year. Okay, scale drawings. Last thing. This is something that if any of you are looking into like architecture as a career, this is something you will use a lot in your career. So a scale drawing is like when they built this building, which feels like just yesterday to me, but it's actually quite a long time ago now, I feel like. How long has this building been here? I don't know. It still feels new, but it's really not that new anymore. They had to make plans for it, right? The blueprints for it. So they figured, okay, for every, well, we'll say that. No, that wouldn't work here. For every inch on our blueprint, it was 10 feet in reality, right? You can't draw a blueprint the size of the actual figure, or you're going to have a ginormous piece of paper, right? So they shrink it down. They scale it down. So when we do scales, you got to figure out what is that scale, what's the relationship, and where are we going with that? So, for instance, you could have a scale where 1 inch represents 100 miles, right? On a map of the world, maybe they do, yeah, that would still be a pretty big map. Anyway, you get the idea. Does that make sense? How you scale it down? 1 centimeter represents 200 meters, or 1 inch represents 10 feet, depending on how big or small the thing is that you're working with, okay? So here's what they say here. The scale on a map of the Golden Gate Bridge. Have any of you been to the Golden Gate Bridge? It's pretty spectacular. I grew up in Northern California, so I got to do San Francisco a lot. It was fun. 1 centimeter represents 200 meters for their scale version of it, okay? Now, I recommend when they do that, you write it like this. 1 centimeter to 200 meters. And so far, everything we've done, we've converted units. But when you're doing scale drawings, as long as you keep the same units across from each other, so centimeters to centimeters and meters to meters, you don't have to convert, okay? So 1 centimeter to 200 meters equals, oh, my pencil's gonna die. It says the distance between 2 towers on the bridge is 6.5 centimeters on the map. What is the actual distance? So if we're keeping corresponding parts together, where would you put that 6.4?
On top.
On top, okay? If you put it on bottom, your answer is wrong every time, I promise. So just make sure you're matching up. 6.4 is centimeters. Some number that we're looking for is going to be meters, right? We're looking for how many meters would it be. What do you do to solve that?
Cross multiply.
Cross multiply. So you get 1x equals 200 times 6.4. You can just plug that into your calculator if you don't feel like doing that in your head. Would be 1,280 what? Meters, right? Make sure you label these because 1,280 centimeters is also very different than 1,280 meters. Okay, so that will be your scale drawing. You're just setting up a proportion, but again, when it's a scale drawing of something, you do not have to convert things. Okay, when it's just a ratio and you're saying here's a ratio to something, that's where we want to convert so we can reduce. But when it's giving you a scale drawing, centimeters to meters will always equal centimeters to meters. Okay? Questions on that? Lovely.